involving polynomial functions, okay? Find a polynomial p of x of degree 3 with zeros -2, 2, and 3 if p of 1 is equal to 18. Okay, so I actually have three information given. First, the degree of the function is 3. Second, the roots are -2, 2, and 3, which makes sense because the degree is 3. And that also means that the multiplicity of each of these roots is equal to 1, right? Next is p of 1 is equal to 18. Remember that uh, y is equal to p of x, right? And so p of x. So this means that if x is equal to 1, if x is equal to 1, then y is equal to 18. So that's how you break it down. So you actually have that information. And so from that, we have this, factored form. And so the first thing that you think is, yeah, that's a factored form, right? -2 would correspond to x plus 2. The root 2 would correspond to x minus 2, and 3 would correspond to x minus 3. But then we don't really know the leading coefficient. It would be tempting to say that the leading coefficient is 1, but if you substitute 1 for x, so let's do that. We have 1 plus 2. Okay. 1 minus 2. Let's just do this slowly to avoid errors. And 1 minus 3. So this should be equal to 18. Right? So it's not A. So 1 plus 2 is 3. 1 minus 2 is -1. 1 minus 2 is -2. And all of that multiplied should be equal to 18. Okay. So 3 times -1 is -3 times -2 is +6. So we have A times 6 is 18. Right? So it turns out that A is actually not 1. But what do you multiply to 6 to get 18? Oops. Then obviously A would just equal to 3. 18 divided by 6 equal to 3. Okay. So therefore, the polynomial that we're looking for is p of x is equal to 3 times the quantity x plus 2, open close parenthesis, x minus 2, x minus 3.